Yep. Good morning, guys. The light is shining on my face, so I'm going to be like squinting a bit. When I move here, let me know if you cannot see me. You can probably hear me, but I'm vertically challenged, so I might be hiding myself here. But welcome, everybody. Good morning. Were you guys, anybody here for the previous session, or is this the first session of the day in this room for you guys? Yeah, pretty much. OK. Enjoying TechEd so far? Yep. All right. So my name is Hema Rajalakshmi, and we're here to talk about managing embedded devices with System Center 2012 SP1. So I'm not going to say the whole name of the product through the presentation because it's long. So I'm just going to say ConfigMan SP1. Is everybody OK with that? All right. I want to be clear that this session is about Windows embedded, not other embedded devices. So if you have other expectations, I'm sorry. I just want to be very upfront with you. This is about Windows embedded devices only. I may be able to answer questions about other embedded devices later, maybe, but the focus is going to be Windows embedded. All right? OK. So let's look at what I'm going to cover. And again, this presentation, I want it to be as interactive as possible. So if you want to interrupt me and ask any questions, feel free to do so. We will have some time towards the end for Q&A, but don't wait till the end if you have pressing needs to get a question answered. So we will take a look at, all right, support for right filter enabled devices. I'm also going to look at, hold on just a second, if you can bear with me. I had a few other things that I wanted to talk about. I don't see it on the deck here, but in any case, I'll talk about it, I guess. So I'm going to talk about intelligent systems and how embedded devices fit in that space. And then we will take a look at support for right filter enabled devices and how we manage right filter enabled devices using ConfigMan 2012 SP1. And we will talk about some of you already, I've spoken to some of you earlier, and some of you already use maintenance windows, and that's great news. But we will still talk about maintenance windows and how you should use them and why they're your friends. And there's a concept called persistence. We will take a look at persistence and how they affect the right filter enabled devices. We have made some improvements in SP1, and I put SP1 plus there to indicate R2. So we will take a look at that too. In the end, we will have time for Q&A. All right, so definitely, if you guys could please bear with me for just a minute. I want to switch the deck because I don't see the one that I updated. It's not here. I'm sorry about that. Can you help me with that, please? OK, just a second. Sorry for the break. So the deck that I'm supposed to have here is not on there. So can I go to the version? Can we go to the folder where this one right here? Yeah, if you go to this place. There's a V2, that's the one I want. This one? Yes. Is that the same? Yeah, they haven't updated it.
Is this the one?
Oh, that's from yesterday. I have this. Can we put this one on there, please? So we will take a look at intelligent systems and how they fit in. Rev 2. Yeah, right there. OK, thank you. That's fine. So slideshow, I'll just do that. Slideshow, OK. All right. So we were here. Like I said, I had one more item in the agenda to talk about intelligent systems. And all right, so let's go. So I am going to start with a big number here, 50 billion. And this is not a number that I pulled out of thin air, but research at folks like IDC and Harbor Research have come up with this number. They've projected that by the year 2020, there are going to be 50 billion connected devices on this planet. Now, think about that, right? That's a huge number, staggering number. So today there are multiple ways that you interact with technologies and devices. And think about in 2020 when it becomes 50 billion devices and the necessity for managing those devices as they connect, communicate, and share data across, it becomes really important. I mean, of course, the number is huge, but then we have lots of good opportunities that we can talk about. So let's put some perspective on these numbers. So today, we have 2 billion PCs on this planet, 5 billion mobile devices, and 7 billion people. So by 2020, we are going to have 50 billion connected devices. And beyond that, the forecast is 10 trillion individual items with smart technologies built into those, right? This really means we have to work on figuring out a strategy for managing those devices and also having a smart way to protect those data and devices and network for us. All right, so what is an embedded operating system? In a nutshell, it's extending Windows to specialized devices. So if you look at it, how do we achieve this? By taking Windows operating system and componentizing those. There are goods and bads. I was talking to some of you guys earlier that by componentizing, we give the power to the OEM image builders, right? The people like you that build the images. So we provide ability to pick and choose the components that apply to the devices that you want to build. So if you want to build an MRI device, image for an MRI device, the components that go into that image are going to be extremely different from something that you would use to build a thin client, for example. All right, so let's take a look at what Microsoft has done. Microsoft has significantly invested in technologies to reimagine Windows experiences using Windows 8, right? Windows 8. Now, the same innovations can be extended to PC or embedded image builders, right? Which means you can use the same technologies and build your images and provide the same power of Windows 8. Now, what are some of the benefits we have? Rich line of business experiences, which means providing your customers with a seamless sort of experience, which delights your customers, of course. The next one is connected and mobile. So you want your devices to stay connected to the resources they need at the business impact point, right? So you don't want your devices, for example, you have a handheld device that always connects to the UPS handheld device that connects to the server. You want it to remain connected so that they can upload the data information that they need. So that ability is provided. Business ready, again, going back to the Windows 8, so the power of Windows 8 is being used to build enterprise class solutions. Security, like I said before, all of these devices are going to share data and remain connected. And eventually, you want this whole ecosystem to be secure. By using enhanced security technologies, you're going to protect the device, the data, and the network. Invest for future. Now, we know that we want to provide you with technology that you can have confidence in, which means if you build a device today using the technology that we offer, you have to have the confidence to provide that to your customers, knowing that this will be supported and there will be investment in the future made to these images. So you can build devices using either Windows Embedded 8 Standard, Windows Embedded 8 Pro, or Windows Embedded 8 Industry Pro, besides all the previous generations of Windows Embedded editions that you've already been using. But no matter which one you use, the core value proposition for Windows 8 remains the same. Right? And by the way, Windows 8 Standard is an extension to WES 7, or Windows Embedded Standard 7. And Windows Embedded 8 Industry Pro is an extension to POS Ready 7 that you have today. And Embedded 8 Pro is nothing but Windows Pro, 8 Pro, made for embedded devices. So it comes with full power of Windows 8 that you can deploy to an embedded device. So it has its embedded enabling features like white filters and everything else added on top of full-blown Windows 8 Pro. All right, so now let's get into the actual topic, which is managing embedded devices. There are certain challenges in managing embedded devices because the embedded devices, for various reasons. So let's go through one by one. So embedded devices, the operating system that go on these devices are very customized, are not homogeneous, right? It's not like PCs or servers, which come with a standard image to be built. So it poses a challenge in terms of coming up with a, say, update pack for these devices, because each device is built with different set of components, which means that's a challenge. Identifying, so till the release of SP1, we had this challenge of identifying Windows embedded device in the config manager ecosystem. When an embedded device was connected or put in the infrastructure, it did not know, it could not identify Windows embedded devices. It would come back as unknown device, and which was an issue for the admins because they did not know which devices were failing to get the deployments or were failing to function. We have solved this in various ways, which I will talk about later, but we have solved that problem. Embedded device designs are widely, so the hardware look and feel of the devices are very different from PCs and servers, and the peripherals that go in there are very different, which means driver updates, any kind of patch is a challenge. Again, OEM embedded device image, that particular point is talking about how the OEMs have a sort of different service model and update model. They normally, some of the OEMs, like in the medical industry at least I know, that they have an agreement with the OEM that they would come into the site and update the devices using their own service and management solution. App management in embedded device scenarios, because Windows 8 applications, we will get into this towards the end as well, but Windows 8 applications do require registration, right? But when a user is logged into a right filter enabled device, anything that they do during that time is not going to persist because of the simple fact that right filters are going to prevent you from making any changes to the device. So that poses a problem. We have a workaround for that, which I will talk about as well. And managing right filters. Right filters are great tools, really great tools for embedded, because you want the devices to be locked down. You do not want the device to be tampered with. For example, an ATM machine, you want a lockdown experience for the end user. An end user walks in, I don't want to have to interact with the ATM machine to be able to deploy something. I don't want to click on something that says reboot now. So I want it to be locked down, and that's why right filters are great. But then management essentially means making some changes to your device. And if right filters are turned on, how are you going to do that, right? So that's going to be a challenge as well. And before SP1, we had this product called Windows Embedded Device Manager, or WEDM for short, W-E-D-M, WEDM for short. It used to be an add-on product to Configuration Manager. So with 2007, you used to have WEDM 2011 SP1, which was an add-on. So it was, you would install Config Manager, and then you inclined, and then you would add on WEDM on top of it, which would exclusively manage embedded devices. So we did not have a seamless solution to manage desktops and other devices and embedded devices in your ecosystem. But with 2012 SP1, we kind of extended that capabilities of WEDM into Configuration Manager. So which means anything that Config Manager could do with a desktop, it also can do the same with embedded devices. So you notice that it has full support. It offers full support for software distribution, software updates, compliance, collections management, and device imaging. So there's full support because it's a natively integrated solution. So let's look at what is supported in 2012 SP1. So there are various, if you want to call those device verticals. There are device verticals called thin clients, point of sales, digital signage, kiosks, ThinPs, and many more. And we essentially support, or SP1 supports, seamless management of these kinds of devices in the infrastructure. Now, which means it boils down to not only can you manage desktop solutions, but also these additional devices like embedded. And some of you probably, if you have attended the overview session, we also manage mobile devices such as iOS and Android. So it's expanded significantly, the range of devices that Config Manager can now manage. And again, the last point here is to say that additional software not required, which means in olden days, when you would have Config Manager, you would still have to add or buy and add VDOM on top of it. So now you don't have to do that to be able to manage embedded devices. And this chart shows you various flavors or additions of embedded operating system that can be used to build some of these devices, and all of those are now handled. So if you wanted to look at OS deployment using Config Manager SP1 for a point of sales or kiosk device, you can now do that for Windows Embedded Industry 8 or XP Embedded as well. Although XP Embedded is soon going to go out of support, so we all urge you to move from XP Embedded to the next version, which would be Standard 7. I don't think that people generally jump from XP Embedded to WES 09. They normally make the transition from XP Embedded to WES 7 or Windows Embedded Standard 7. That's the practice. So, all right. So within SP1, what are we able to do? And why do we do this? Operating system deployment, or OSD, is supported for embedded devices. And underneath the covers, it uses Windows ADK. Software update management for OS servicing, like service packs, Patch Tuesday comes, what do you do? Use software update management point. And application management so you can deploy and manage Win32 applications as well as Windows 8 applications on an embedded devices. And we will talk about the challenges with Win 8 applications in terms of registering those, but you can still manage those applications. And we have settings and configuration management using baseline. So you can just create a baseline as you would for any other desktop solution. You can create configuration items, wrap those in a baseline, and then deploy those to an embedded device as well. And you have the full ability to monitor and report on compliance statistics or deployment status or anything that you would do with Config Manager for an embedded device. So we have added capabilities so that embedded device is now no longer different from other devices. Endpoint protection is used for anti-malware protection. So you can update signature or virus signature updates, send all those deployments to an embedded device as well. And the bottom right corner there says single pane of glass. This is what I was talking about earlier, that we now offer an on-premise solution for 32-bit and 64-bit architectures and Intel SoC. And we also offer the cloud-based solution to manage Windows Phone, Windows RT, iOS, and Android, and all that. But to an admin, to an SCCM admin, they all look the same because it's a single pane of glass that he uses, one admin console that he or she uses to manage both the on-prem type of devices as well as the cloud-based devices. So they don't have to learn new technologies or products now. And the embedded goes right in there too. All right, so how do we do this? By orchestrating write filters. So as you all know, write filters are the major roadblocks, right, for managing any device because they prevent any major changes to the device. So what we do is we orchestrate the write filters, meaning we disable when it needs to be disabled, make the changes to the device, and then re-enable because you want it to be locked down in the end of it all. And we have implemented maintenance windows. So you can create a collection of embedded devices and configure maintenance windows on those and apply the updates or deploy deployments during the maintenance windows. And it will orchestrate the write filters during that time. There's a concept called opportunistic and forced persistence. So you want to persist. So what happens when you persist? You want to persist a change to an embedded device? Anybody? What happens when you change the state of write filters? It reboots, right? So it changes. So when you want to make a change to the device, you first have to turn off write filter, which results in a reboot. You make changes, and then you want to re-enable the write filter, right? It reboots. So 2 reboots, that is per change. So every time throughout the day you make changes, you have a set of 2 reboots every time. So we want to opportunistically persist. What does that mean? So I don't want to make changes right away. I want to queue up everything that's important to me or my device, and then update the changes at once so that I don't make too many reboots. But there are certain critical updates that I want to apply right away and force it to persist right away. Like, for example, a signature file update. You don't want to wait for an opportunity. You want to persist it right away. You don't want the device to be attacked by any means. So there are 2 kinds of persistences. We'll go through it in detail later. And I talked about anti-malware support through endpoint protection. So SCEP has its own client, or System Center Endpoint Protection has its own client as well. Now, on the write filter enabled device, you want it to be committed. You want it to persist. So we have a mechanism by which a SCEP client install will persist through orchestration as well. And the SCEP updates, like I said, the antivirus or virus signature definition update file, they can be forced to commit right away. And again, no additional software required. So you don't have to worry about, oh, do I have to add something else on top of SCCM to be able to manage all these? No, it all comes inbuilt. All right, so what are filters? So additional lockdown, right? So you have group policies to lock down or control the use of a device. But this is a built-in feature for embedded device where in the image you can turn on write filters. There are various kinds of write filters, and the new type of write filter called Unified Write Filter, or UWF, has come with Windows Embedded Standard 8. Before that, you used to have many others, but primary 2 filters used to be Enhanced Write Filter and File-Based Write Filter. And you used to have registry filters, gesture filters, keyboard filters. They all still exist, but with WES 8, we introduced something new called Unified Write Filter. It's a wrapper around Enhanced Write Filter and File-Based Write Filter. Okay? And it prevents a change of a state up to the device. So it locks down the state of the device. So you let in a user, and till the user logs out, the state of the device is going to be changed. But then once you reboot, it's not going to persist. So the next user comes on, it's going to be a fresh startup, a fresh device configuration settings. So enhances security, of course, you know, nobody can tamper with the device during that time frame when the write filter is enabled. So there are other customizations, especially with write filters that you can, unified write filters that you can do. But with file-based write filter and enhanced write filters, you can turn on, turn off. But on top of it, you can also configure exclusions for file-based write filters. So for example, you don't want to completely lock down a device. You want certain parts of the device changeable, right? Maybe a few registry keys are OK to be updated. You can define the exclusions for registry filters or file-based write filters. You can say that for this particular folder, I'm OK allowing some changes to this particular folder or file. So you can configure exclusions with file-based write filters, not just turning on and off. And then if changes are made, of course, reboot restores the known state. And all of these write filters apply to all the vertical devices that I talked about, including ATMs, kiosks, digital signs, thin client, MRI machines, or any sort of embedded device that has a write filter deployed to the image. All right, so let's take a closer look at what write filters and overlays do. Okay. All right, so I have a device with write filters turned on. And a deployment comes down to the device and says, I want to apply the deployment. I want to apply myself to it. It just applies. It writes itself and all that. But then with reboot, it's gone, right? So what is our solution? We have to somehow unlock the device, meaning we have to disable the write filter so that when the deployment comes in, it writes, and then when it reboots, After reboot, we also enable. So that way, you are allowing some persistence to happen. And what this one says is earlier on the right-hand side of the screen, it says that earlier with System Center 2012, we used to be able to manage PCs and mobile and the devices, mobiles and servers. And embedded VDEM used to be the case for management authority for all these embedded devices. And now we have unified that. So before we jump into all of the other concepts, let's take a look at maintenance windows. Some of you are very familiar with maintenance windows, but I'll just give a quick overview of maintenance windows and why they matter. Let's consider the case that it's a 4 o'clock on a Wednesday, and a deployment comes down, okay? And it's marked as ASAP, which means deploy me right away. I don't want to wait for anything. Just deploy me. And notice that the write filter is enabled on the device. Now, because the deployment came down, it needs to do something so that it persists. It's an ASAP, persist me sort of deployment. So it reboots, does its thing. Think about it. If it was an ATM machine, you were right in front of it. You inserted your card, and you're trying to get some money out of it. And in the meantime, it has a deployment that says, ASAP, now reboot me. You're not a very happy customer, are you? So it's not a great situation to be in, or even for that matter, if it's a controller in an car assembly line, you don't want this to happen. So how do you get around this? You want to have the ability to define maintenance windows, which means for an ATM machine, maybe midnight 12 to 3 o'clock early in the morning is a good time to maintain the device. Or maybe for a controller in an assembly line, maybe it's 2 a.m. to 3 a.m., maybe an hour or 2 hours. So you want to be able to define maintenance windows and configure your deployments to only be targeted at that time. That's what maintenance windows essentially allow you to do. What happens without a maintenance window? The system gets a deployment notice, which means it says, OK, I have an update to apply to myself. And it downloads the content. So here's the concept. So deployment notice comes from the server, and it has an element in it that says, OK, you get my content from someplace else. The content does not come with it. So for example, if it's an application update, the application itself doesn't come with the deployment. It sits on the distribution point, which has to be then downloaded. So then it goes and downloads the content based on the instruction there. It knows that it's a write filter enabled device, so it disables write filter and reboots. So it has remember that it has already downloaded the content, right? Now, it downloaded the content before the write filter was disabled. So what happens? It disappears after the reboot. So the content has disappeared, but it still knows that I had a deployment that I had to apply. So it still keeps track of that and says, oh, all right. When it reboots, it gets the machine policy and says, all right, now I have a deployment. I have to go get the content again because I don't have the content. And this time, it is going to persist because notice how the write filter was disabled with the previous download. Right? So it downloads the content, installs the content, re-enables write filter, and reboots and all that. So everything is happy. What's the slight problem here? It downloaded the content twice. It's OK if it's a small set of content, but if it's huge, like an OS deployment or something like that, you don't want this to overload the network or the server. You want the download to be optimized, reboot to be optimized. That's our goal, right? So with a maintenance window, what happens? It gets same scenario. It gets a deployment notice. But it knows that, oh, I am in a collection of devices with a maintenance window configured, right? So is it 4 o'clock yet? Maybe not. So waits for the maintenance window. And now it's 4 o'clock, so maintenance window has arrived. So I am keeping track of that, and I'm saying, all right, now I need to disable. I don't want to download the content, because if I download it now, it's not going to persist. So I am going to disable the write filter. So it disables the write filter, reboots, and after that, it now downloads the content. So notice how there's only one download of the content. And then install the content, reboot, re-enable the write filter and all that. So everything happens happily. But it's just that we're saving some amount of network traffic, server load, and time. that's the whole point of maintenance windows. Okay, so there's a concept of persistence. This was not necessary for standard desktop devices because anything you apply will apply right away, persist right away. But with right filter enabled devices, you have to be explicit about, okay, I want this to persist now or later or like when, right? So you had to do that. So what happened was we added, see the last checkbox on the bottom of the screen, that's what we added. And it's a bunch of words there, but essentially what that means is I want to commit this change ASAP. So do the right filter thing, which means do all the magic, right filter magic at the deadline, or better yet, at the maintenance window. If I know there's a maintenance window, just wait until the maintenance window. But don't, like, I want to commit this as soon as possible. That's what that means. All right? And without persistence, the same thing. If you uncheck it, if you leave it unchecked, that just means that put me in the overlay, like any update that comes along, just put me in the overlay. Don't make the change. When another deployment with the same flag set comes along, which means it needs to be persisted right away, then bundle me with that guy, right? So this could be a case where you want 5 or you know that 5 or 6 different deployments are going to go down to this device, and you want to mark everything else to not persist, and one of them, the last one, to persist. So you can kind of bundle them all together and send everything to persist. So this will minimize your number of reboots too. All right, so what can be forced to persist? Unfortunately, we haven't enabled this option for every single deployment type. This forced persistence option, the checkbox that you saw there, is only available to 4 different types of deployments. Applications, when you deploy an application, you can select the option to persist. Packages and programs, software updates, and task sequences. However, for the other 3 on the right-hand side, we do not have a support today, or as for SP1, or even for R2 for that matter, a forced persistence story for these 3 types. Client agent settings, what are these? These are machine policies that get applied as soon as the device is rebooted. So does it matter that it doesn't have a forced persistence option? Not really, because every time the machine reboots, this policy is downloaded and these settings are applied anyways. So it doesn't matter, because you don't get the client agent settings through the life of the session. It only is applied at the beginning of the machine reboot. So we are OK with that. DCM, or settings management, you cannot persist it. Now, if you want your, say, for example, your home page, your intranet page, home page has changed, and you want to deploy this policy to all the people in the enterprise and say, I want this home page link to change. It's not going to persist right away. It's going to wait until the next. So in the meantime, what happens, the users are going to try and launch the link. It's not going to work. So we understand the problem, but there's a workaround to making it stick right away. So what you can do is you can bundle a settings management policy with an empty package and program that just has a checkbox on that says persist me right away. Send these 2 together, and what do you get? You have a forced persisted settings management. So these are some tips and tricks, by the way. And power management also does not come by default with a forced persistence option. Again, you can do the same sort of workaround with power management. Send the power management policy with an empty package and program with the persist option, and you get the same result. Any questions so far? OK. All right, so there's one more slight issue with persistence, especially for embedded devices and right filter enabled devices. I'm sure all of you have heard of state messages and inventory data. Yes, no? You guys all heard state messages? OK, great. I think some of you have. OK, so anytime a client needs to update its state or its status, it sends a message called state message to the server. It says, OK, I'm healthy, for example. I'm active. I have a good heartbeat. It's going to send those messages to the server. That's called sending a state message. Inventory is like just identity of the device, right? What's my CPU? So any WMI property of the device is sent to the server frequently. And it's all configurable. Typically, these inventory messages are sent once a week, and we recommend to keep it once a week because the data is huge. Now, what's the real issue with persistence for those So inventory data, the first set of inventory data is collected from this client to server. It is supposed to keep track of what it has sent to the server. Only then it knows to send the difference next time, right? So notice that write filter was enabled. So it could not write the first inventory data on itself to keep a copy of it, right? It did not. So what it did is it's supposed to send a delta next time to the server. Instead, what it did was it sends the first inventory message again because it had no way of knowing what it already sent. So it keeps sending first inventory data to the server, and server thinks, oh my gosh, I'm getting the first inventory data from the same machine over and over during the course of these couple of days. So the server definitely is confused. It says, okay, now I think there's something wrong with the client. So it sends something called a resync. So a resync request goes from the server to the client and says, okay, go get fresh information about this client all over. Let's start it from fresh. So that's a lot of load on the network and the server too. It's actually going and getting this data, and it's doing this multiple resyncs every day, sometimes multiple times a day or sometimes multiple times a week. You don't want that to happen. So what's our recommendation? File-based write filters. Now, file-based write filters protect the files, right, folders. So what can you do? How can you get around this with file-based write filters? Inventory data is written into SQL CE database. So we have SQL CE database sitting on the client, on the device itself. And that's where it stores the inventory data and state message data. SQL CE is nothing but a file, right? So with file-based write filters, you can configure exclusions. And you can say, you know what? You can lock the entire device, but leave this folder alone. Leave the SQL CE folder or database alone. Let it not be protected. So then what happens? So every time the first inventory data is sent to this server, it does write a copy to the SQL CE database because it is not locked from being written to. So next time onwards, it's only going to check to see what it has already sent and sends a delta, so everything goes happy. That's why we recommend, you'll see that we'll recommend using file-based write filters. I know that some of you are using XP Embedded, for which the default write filter is enhanced write filter, right? We know the pain point of changing that to a file-based write filter. You don't have a choice but to reimage the devices to actually enable file-based write filter. We're trying to figure out if there's a way to easily push down a script that can help you switch the filters. So again, write filters protect system against write operations. So you can easily create read-only devices. That's a great feature of write filters. You can create a lockdown ATM or kiosk machine that is read-only device. And of course, improves system uptime. Since there's no writes happening to the device, there's nothing else going wrong, or you don't foresee any reboots or changes to the device. So it improves uptime. And the chart here, this deck, by the way, will be shared with you all after the event, I think. So this chart is a great reference chart for you guys. It shows you the different kinds of write filters, and it shows you what it supports, and in which, like Embedded 8 standard has all three. But industry only has UWF, which is Unified Write Filter. Just make sure you note that because the older write filters are not available on that image, Industry 8 image, which is the next version of POS-Ready, by the way, POS-Ready 7. Any questions so far? OK. So again, we do support natively file-based write filter management and enhanced write filter management. Like I said, in SP1, unified write filters is not natively supported. However, there's something called a servicing mode. We have a WMI provider written just to work around this situation, because we know some of you guys are experimenting with Industry 8, and for which you do need unified write filter support. And so there's a WMI provider that you can use to query and then disable the write filter and do your deployments and then re-enable them. So there's a WMI provider. And outside of Config Manager, there's also something called Embedded Lockdown Manager, or ELM, which can be downloaded from, I think, a Download Center of Microsoft. and which is nothing but a snap-in, MMC snap-in that you can use to manage your unified right filters as well. All right, so this is just capturing what I just talked about. Right filter awareness natively built in for OS deployment, software update management, application management, and endpoint protection. But for settings management and monitoring reporting, there is not a built-in right filter awareness, but there is maintenance window support and policy support for those. All right, so let's look at some examples of software. So let's take an example of software update for a file-based right filter enabled device. What does the admin have to do? These are a few steps that the admins would have to exercise. So admin first has to select the updates that he wants to deploy to the device. Then when he deploys the update, he checks the checkbox and says commit right now, right? Force persist right now. And then he says, which collection of devices do I have to push this to? So embedded device, hopefully they would have a collection for embedded devices, and pushes the updates. And since it's software update, which is natively supported by Config Manager, the whole right filter orchestration happens, and the update is applied. And in the end, the device is right filter enabled as well. So it's locked down. OK, same software update with unified right filter. I told you that it's not natively supported, right? So how do I do this? Now, the task sequence is your workaround. So you can create a task sequence. Remember I told you there's a WMI provider. Also, there's a switch for UWF to enter into a servicing mode, which means it can enter into servicing mode, during which time nobody will be able to log into the device. And then you can push whatever deployment you want to push. And then you'll add a task for rebooting the device. So that's what it does. Admin creates a task sequence. The first one is a command line task to enable UWF in servicing mode. And then you apply, so it'll wait for the deployments to arrive. And then your devices are updated. And in the end, it'll execute the last task, which is reboot the device. All right, so this is another, like I said, ELM is a snap into MMC and any type of right filter, not just UWF. It basically can manage any type of right filter enabled devices. All right, so some of the improvements to recap is that we have right filter orchestration for all of these different types of deployments. Note that SP1 only supports FBWF and UWF natively, but it can support UWF through task sequence. We also have made a couple of improvements on the server. So in olden days, with 2012 even, I think, that when you were to run an operating system deployment, OSD, what happened was the content used to sit on the distribution point. It used to be downloaded to the device locally and then run. Think about a small form factor embedded device, a thin or zero thin client, right? You don't have the luxury of downloading the content onto the device and then running it from there. So what we did was to support just that embedded scenario. We added a variable called apply operating system, which what it does is it runs it remotely from the distribution point. So it doesn't download the content locally, so which is a great improvement, I think. And we also added a new task sequence variable called SMS task sequence, or TS, post action. This is particularly helpful to enable right filters in the end of any set of tasks. So in the end, you just add this variable and say SMS post TS post action equals true, and then it'll just enable the right filter. And now we also have a new DDR, or discovery data record, because of which, remember one of the challenges I talked about is that we could not identify embedded devices in the ecosystem. And this is what we did. So what we did was we added a filter, which is now, you can query based on that, and it tells you that a right filter capable device is found. And then you can, based on that query or that criteria, you can create a collection of devices. Or you can take any sort of actions based on that criteria, which only applies to the embedded devices. So if you have a mix of devices in your enterprise, then you can filter, right, filter devices separately using this query. All right, so we also made some other client-side improvements. Non-admins, so when a device is being serviced, what happens is a deployment comes down, and it knows that the write filter is now turned off and rebooted. Think about what happens if the user is now logged in. Any changes he or she makes is going to persist forever. You don't want that. So what happens is at that particular moment when the write filter is disabled and rebooted, the normal user is kicked out of the system. Only admins can then log in until the servicing is done, which means until all the deployments are applied and the write filter is turned back on. So we called it a servicing mode, and you will see a nifty little window just like that on the top or bottom right corner that you see on the screen. That's what you will see. The computer is being serviced. Only users who have administrator privileges or permissions can log on at this point. Software Center blocks installation if write filter. Of course, you don't want Software Center to start installing stuff because after the reboot, it's going to go away anyway. So we have kind of blocked Software Center installation so if write filter are enabled. And users cannot change their business hours. You don't want them to change. This was a requirement from a couple of major embedded enterprises that said, we do not want our users to change their business hours or postpone their non-business hours. So we kind of cater to those as well. I believe that many of the enterprises now are using this feature. OK, so what are some of the considerations? We talked about it, just a recap. Settings Manager is not write filter aware natively. So you can manually handle write filter by task sequences, or you can use an opportunistic persistence window and bundle it with a forced persistence deployment. OK, so coming to the next one, which is Windows 8 applications. So every time Windows 8 applications are deployed to a device, to a user, in fact, it's effective when the user logs on. And that's when you have to register the applications. But every time the machine reboots, since it was a user logon session, you're going to lose all the applications. If it's a fewer number of applications, then re-registering is an option. But if not, if you have many applications that are being deployed to the Windows 8 device or Windows embedded device, then your alternative is to have an admin log on during this time frame to finalize the registration. Unfortunately, we don't have another workaround for that. And skep installs will persist. Updates do come frequently, which means there are multiple reboots. And you can add write filter exclusions to the files or folders where the signature updates happen, or it can be manually set. We also added a new setting for endpoint protection client installation. The last one that says commit endpoint protection client install, which actually commits it to an embedded device. And it's the same thing. All right. Now, so what are recommendations? Plan for persistence. Please do plan for persistence. Don't start deploying stuff right away. Think about which ones you want to force persist, which one you want to opportunistically persist, which ones you want to bundle, how many times do you want your devices to reboot. And so plan your persistence. Maintenance windows are definitely your friends. I mean, if you are able to set maintenance windows, then that's best. The only caveat there is that make sure your maintenance window is long enough to accommodate the largest deployment. Meaning, if a deployment takes 2 hours to complete, and you have set your maintenance window to 1 hour, it's not going to fit. It's never going to be applied, because every time the maintenance window comes along, it's going to start the deployment, but then it has never ended. So so make sure your maintenance windows are longer than your deployment length duration. And then we have client inventory and state persistence that we talked about. All right, so I do have an appendix that talks about, that has a list of exclusions for file-based write filters that you can configure for the skep to persist. And these exclusions right here are the exclusions that you would configure to persist state and inventory data, because they're in SQL C database. All right, so the exciting stuff, right? What's new in R2? So I said so many times that UWF is not supported natively in SP1, but that we have overcome. So now with R2, we have UWF natively supported. Yay! So yes, so we have supported that. So you don't have to worry about the task sequences or the ELM or the WMI provider. Now it just can be treated like any other device. And we also have support. So if you are building a collection and if you're deploying sending deployments down to devices, and if you want to restrict it to certain embedded editions or operating systems, then now the list also includes Embedded 8 Standard, Embedded 8 Pro, and Industry. All right, so I want to go into show you a quick demo of things. So what I have here, I'm going to look down because I have another monitor here that helps me view what's happening with my thin client. So I have a thin client here, which has an embedded 8 image sitting on it with file-based write filter. The reason I have file-based write filter there is because my server sitting on this big laptop is SP1. And since SP1 cannot natively manage UWF, I chose to deploy FBWF on my thin client here. All right, so this is my thin client device. And let me switch over to actually my configuration manager server machine. Okay, so this is how many of you have seen SP1 console? How many of you have not seen SP1 console? Oh, yay, everybody has seen SP1 console, which is good. So what I'm going to show you is, okay, so let's go through this. Let's go through an exercise where I'm going to create an application package, okay? And I'm going to deploy that to a collection of embedded devices. In this case, I only have one embedded device, which is my thin client in my collection. And I'm going to deploy that and show it to you that it shows up in the software center and how it goes into a servicing mode. Hopefully, there's enough time for me to switch over and show you the balloon that shows up as well. So I am going to first show you, I want to make sure I don't miss out on anything that I wanted to show you. Okay, so let me show you the collection. So device collection has a collection called Demo TC, which is thin client collection, and there's only one member, right? There's only one member, which is WE Embedded 8 Standard Demo machine. And then I'm going to create a package. And I have a really lame program called Rich Copy, which is what I'm going to use for this demo purposes. And I'm going to create a TechEd demo package. This package contains source files. I'm going to local. It's local. I have it on my, and I have something called Rich Copy. All right. Okay, standard program. I'm not going to touch this. Okay, so let's call this Rich Copy Program Deployment. All right. I'm going to select that, and I like to do a quiet install. All right. So this is all good. I'm not going to change anything else here. And I want this to run on any platform for now. I'm not going to change that either. All right, so I created a package with a program, but that doesn't mean anything, right? You all know. So that's a TechEd demo package. Okay, so now before I deploy that, okay, I can actually go ahead and deploy that. Before I deploy, I need to look at the content status. It still is not, there's no content. So what I'm going to do is distribute content. I'm going to point to the distribution point, the only distribution point that I have on the system. All right. Okay. So hopefully this will refresh it. So look how it's green. Yay, that's good. All right. No, not that one. Sorry. Okay, there you go. It's still green. All right. So now I'm going to deploy. There are no deployments of this package yet. I am going to deploy this. Deploy it to the collection, which we know is the demo TC collection. And the content that's coming from the distribution point right here. Okay, so we want to definitely make sure it's not available, because what happens if you select available, it's going to show up as available to the user, but no matter what they do, it's not going to allow any install because this right filter is enabled. So you want to make it required. Required. And scheduling. In this case, I'm going to add it as ASAP, as soon as possible. All right, and I want to see this on the Software Center. So that's why I check this box that says allow users to run the program independently. It's not going to allow it to run independently, but at least it's going to show it on the Software Center. Okay, there you go. This is the persist, force persist. Okay, this checkbox right here. The wordings are a little different from what I showed you on the deck. So. Yeah, just go with this wording. This is the wording. And I'm not going to force persist this right now. So I'm going to wait for a little while. Okay. Pardon me? Oh, yeah, but it's already downloaded, so it's not going to do it. It's already it would have done if I hadn't distributed the content. Not necessarily. Not necessarily. You don't have to. So you can distribute the content, and you don't have to run from distribution point. Yeah. All right. So let me see what happened here. Oh, I have to switch to 2 at this point. Hopefully. OK, this is my thin client. And hopefully, I can ping. I want to make sure I ping, and I'm able to talk to my server. OK, I am good. All right. So I have a few things open here I wanted to show you. Something called Policy Spy, which is a tool. I believe you can download this. Anybody here know if you guys have used Policy Spy, downloaded Policy Spy at all? OK. I have to find that out, and I should let people know. Maybe put it on the SharePoint or something like that. But I use something called Policy Spy, which is actually very cool because you can request policies here and also see what's happening. And it shows you the errors and a lot of status updates right here. Hopefully, you guys can use it too. And then this is our config manager, a client UI. And what we want to do is machine policy. We want to retrieve that. And I have my Software Center open. OK, so oh my God, it was too quick. All right, so it is actually, if you look at it, it's downloading. Do you see that? So it's actually downloading the content. All right, it's actually installing too. It was too quick, wasn't it? It probably already showed the balloon notification that said, oh, there's a software update that requires your attention. It usually pops up. And since I was on that machine, I didn't see that. Here, apologize. But it normally shows up right there. And then it says right filter utilization, critical utilization. Well, I have a very small device. I don't have enough hard drive space. So that's probably why it's saying that. So we will have to reboot the machine later because of the situation. What happens is that it says this is going to reboot now. And I can actually show you what happens when I reboot. In fact, before we go there, I want to show you FBWFMGR, which is the File-Based Right Filter Manager, which is a utility that comes with the embedded image. And it shows you, if you run that command, it shows you the current state. And it is enabled, right? It shows the current state, and it also lets you enable or disable right filters and configure exclusions and all of that. That was that. And I want to restart the computer. I will restart it. And I want to show you while it's rebooting, I want to show you one more thing, the task sequence. Remember we talked about the task sequence that we want to create in SP1 to manage unified right filter devices. So yeah, software library. Where am I? Where am I? Software library. Yes, right here. Oh, okay, I can't see this thing. All right. Okay, there we go. Task sequences. And I actually have a task sequence. I think I created it. Actually, let me go ahead and create one. No big deal. Okay. Create task sequence, and then create a new custom task sequence. That's what we want. And this is UWF TS task sequence. And this is just creating the task sequence. Now we have to add the tasks, right? Edit this. Okay, add a task sequence. General, and then run command line. This is where you would add the UWF servicing task. So you would say UWF mgr.exe and then servicing enable. That's what you would do here. And you can run this at a particular on a particular account or not. But I think that's what we would normally do. Sorry, that was not where I was supposed to enter. Right here. Okay, and apply. Now the other task, remember we added was restart the computer. And that you don't have to do anything at all. You want to notify the user before restarting? Yes. And then you would deploy this. Right now, since I don't have a UWF on this collection, I'm not going to deploy it. But it's as simple as that, the workaround for managing the WF. And then you can send any deployments along with that. In this case, okay, so it did complete everything that it needed to complete, unfortunately. So what should have happened? So what happened was it rebooted and it actually applied the which copy onto it. And in fact, it also had a lock screen in the meantime, which said cannot log on at this time. You have to have administrative privileges to log in. So that's where we are. And that was the demo. Anything else you guys want to see on the either the server or the client? Yeah, it's too early. The reason this error message is popping up is because the services have not started yet for the config manager client. That's why software centers, you have to give it a couple minutes before you can actually, it can actually start up completely. So that was the end of my demo, unless anybody wants to see anything else or open to questions, I guess. Yeah, sure. Correct, yeah. So because the user has logged in when the application package comes down, Windows 8, and it needs to finalize the registration. So what will happen is an admin has to actually go and log into the device. You have to have, or the user has to have an administrative privileges on the device to be able to register, finalize the registration. Any Windows 8 application deployment. Only Win 8. Exactly. Yes, exactly. Only the Windows. Yeah. Correct, exactly. And I believe you have enhanced right filter on it. So you have no choice of excluding anything. So yeah, your only choice is to turn off the right filter, correct? Till you can swap out the right filters from enhanced to. Yeah, we are working on a script to be able to push, and that should come, if everything goes well with the script that we're trying to figure out, we should be able to publish that on the embedded blog pretty soon here. Yeah, yeah. XP embedded support was supposed to end in 2014, but we did extend it out to 2016. Exactly, exactly. Yes, yes. It will be a scheduled job. Yeah, yeah, yeah. Exactly. Any other questions? Great question. Sorry? Oh, when? Correct. No, so we don't have a story roadmap for ThinPC post Windows 7. I'm sorry. Yeah, because even the Windows 7 ThinPC was not on the roadmap, but there was enough demand for it that we ended up creating a ThinPC for Windows 7 based ThinPC. But there's not a roadmap for Windows ThinPC. But who knows, there might be one for next version. Yeah, sorry about that. Yeah. Yeah. The folders, you mean? No, the exclusions, no. So not everybody, so the reason being, not everybody configures inventory collection. So the SQL C database is not always present. It depends on the enterprise and how the admins want it. So we don't have anything out of the box to say exclude that's a great feature ask though for future. If we have right filter or if we have inventory collection, then we should probably automatically have an exclusion for that. It is installed automatically, but it's not written into till we start using the inventory and state message collection. So if that's not configured on the server, correct, exactly. Yes, yes. Yeah. Yeah, no problem. Sure. Oh, so instead of overlay, you're saying write it onto a flash before the. So what are we gaining by that? What are we achieving? Got it. Got it. So yeah, so something what you're saying is if you can download the content ASAP onto a local place somewhere, like a flash drive or something, but apply it during the maintenance window. Got it. That's a yeah, yeah. Yeah, which is not protected, of course, right? Yeah, great ask. Thanks. Yeah, that's a great ask. All right, thank you, everybody, if there are no questions. But I'm here for some more time if you want to come by and talk to me. Thanks. Thank you.